The Math Center presents Compound Probability using AND. In this presentation, we'll talk about calculating probabilities involving selection of colored balls from a bag using the conjunctive AND. Then we'll use the conjunctive AND to solve probability problems involving selection of playing cards. Finally, we'll talk about calculating probabilities using the conjunctive AND in a data table. The word AND in probability means to multiply. We will want to multiply the probabilities of two or more events you are considering. Remember that AND means that you have to consider all events that are happening. It could be two or it could be more than two. Let's look at an example. Suppose a bag has 4 green balls in it, 3 blue balls, and 1 red ball. A total of 8. That's important. Select one ball, replace it by putting it back in the bag, and then select another ball. It's important to note that you might select the same ball twice, or you may select different balls each time. What is the probability of blue on the first draw and blue on the second draw? There are 2 draws here, and because we have AND in the question, we multiply the probabilities together. The first draw, the probability is 3 out of 8, since there are 3 blue balls and 8 total balls in the bag. Since we replace the ball back into the bag, the second draw will be a probability of 3 out of 8 as well. Multiply these together and you get 9 out of 64. This is about 0.14 or 14%. In our second example, let's consider the same bag, but we will draw with replacement. Find the probability. You will select a green ball followed by a red ball. Since we have an AND in the problem, we'll multiply the probabilities together. For the first ball, there are 8 balls and 4 of them are green, so the probability is 4 out of 8. For the second draw, we have 1 less ball in the bag, since we didn't replace the first pick. There is only 1 red ball in the bag, so the probability of picking red on the second pick is 1 out of 7. Multiply these together and you get 4 out of 56. This can be reduced to 1/14, and that could be made into a percent, in this case 7%. Next, let's do an example with playing cards. 2 cards are selected at random from an ordinary deck. An ordinary deck of cards has 52 cards in it. Find the probability of a jack and then a king. And again, notice we do not replace. Since there are 4 jacks in a deck, 4 out of 52 will be our first card. For the second card, there are 4 kings in the deck, but we have to reduce the denominator to 51 since there are only 51 cards left. We multiply these together since we have an AND in the problem, and we get 16 out of 2,652. This works out to about 0.6%, which tells us that less than 1% of the time we'll draw a jack followed by a king. Next, let's consider an example that uses a data table. In this data table, we have athletes tested for use of steroids. A survey was done. 143 athletes were found to have tested positive, while 157 were found to have tested negative for use of steroids, and there were 300 in the survey. We want to find the probability that both athletes that were selected tested positive. Find the probability of the first person testing positive and the second person testing positive. Since we have the AND in the problem, we will multiply the probabilities together. For the first selection, we have 300 people to pick from. 143 of them tested positive, so the probability will be 143 out of 300. For the second, we remove one positive athlete, so now there are 142 positive athletes left out of 299. Multiply these together and you get 20,306 out of 89,700, which simplifies to 22.6%. So, on average, 22.6% of the time, we can expect both athletes to have tested positive for use of steroids. In summary, we want to note that in probability, and means to multiply. Multiply those probabilities. Also, be aware of the words replacement and do not replace. Do not replace will result in a drawdown of the card probability, object, or individual's probability. Thank you for watching this presentation on compound probability using AND.